In Unit 3, we're talking about the laws of supply and demand, which are some of the more famous principles of economics that you've probably already heard of. This video is going to be one of the more technical videos we do throughout the semester. So once we have a supply function and a demand function, this video is going to cover how to solve for equilibrium price and quantity. It's going to cover how to graph these on a graph. It's going to cover how to calculate consumer surplus and producer surplus. And then we're also going to introduce a tax and see what happens to equilibrium with the tax and see what happens to producer surplus and consumer surplus and what deadweight loss it creates. So we're going to be using a little bit of algebra. We're going to be using a little bit of geometry. So we'll walk through each of these and how to calculate these in turn. So here's what our example looks like for this round. In this example, let's assume that the quantity demanded for a given good is equal to 10 minus P, which is the price. So the quantity is equal to 10 minus whatever the price is. And in this market, the quantity supplied is P minus 2. Okay, so these are what we call the demand and the supply functions. So let's first talk about what this might look like on the graph. How would we go about graphing this? So on this graph here, we have price along the y-axis, as always, and we have quantity along the x-axis. So if we wanted to plot what these lines look like, the easiest way is maybe just start with plugging some of the prices in and plotting them along the graph. So if we look first at this quantity demanded, 10 minus P. Well, if P is 10 here, what would the quantity be? Well, 10 minus 10 is 0. So at the price of 10, the quantity demanded is 0. Good. Let's look at a price of 5. So if the price was 5, the quantity demanded would be 10 minus 5, which is 5. So a price of 5 and there will be 5 that are demanded. And then we also might imagine a price of 0. If the price is 0, then 10 minus 0 is 10. So now I've kind of got these points. This is going to be our demand curve. So we can draw this in here. There's our demand curve. Okay. We also want to try to draw the supply curve. So let's start on this axis here. If let's start with the price of 2, right? That looks like it'd be easy. So price of 2 minus 2, so quantity supplied would be 0. So we can plot that in there. And if we go to a price of 5, 5 minus 2 is 3. So at a price of 5, there's 3 demanded. Okay, and let's go up to a price of 10. Price of 10 minus 2, that'll be 8. And so now we have our supply curve. And we can fill this in here. Okay, so right here we have demand, and this is supply. Now, in looking at this, we can already see where the equilibrium is, right? This is the point where these two curves cross. So right here, our equilibrium price is going to be $6. So we're going to call this P star. And our equilibrium quantity here is $4. So we're going to call this Q star. Okay. Now, also, that's one way to solve it graphically. Now, it's not always the case that this lands exactly on one of the prices or quantities here. So we also want to talk about how to solve this algebraically. So using algebra, we can solve for the P and Q that sets these two functions equal to each other. So the first step is to put them equal to each other. Okay, so we'll start with 10 minus P is equal to P minus 2. Now to solve, we want to put like terms on the same side. So here I'm going to add 2 on this side, which means I'll add 2 on this side. So I have 12 minus P equals P. And now I can add P to both sides. And so I end up with 12 equals 2P. And I can divide by 2 on both sides. And P equals 6. And we can see up here that that's exactly what we found, that the equilibrium price is 6. Now, once we found the equilibrium price, we can plug this back in to either one of these equations and it will give us the equilibrium quantity. So 10 minus 6 is equal to 4, and 6 minus 2 is also equal to 4. So you can see here that 4 is going to be our equilibrium price. Okay, so we've kind of solved now for the equilibrium conditions of the market. The last thing that we want to look at equilibrium is we want to look at consumer surplus. So now if you remember from talking in class and in the readings, the consumer surplus is the difference between what the customer was willing to pay and what they ended up paying. So the demand function, remember, is the difference. It's basically made up of their willingness to pay. So here at 9, I'm going to change this to red here. So at 9, this customer is, or a quantity of 1, this customer is willing to pay 9. But if they end up paying 6, then this distance right here, this is the consumer surplus. Now you can imagine at every single one of these price points, this is all consumer surplus through here. Okay. So I'm just going to actually just fill all this in here, and we're going to call this consumer surplus. Okay. And then we also have producer surplus. So if you remember, this is the difference between what the producer is willing to sell it for and then what they actually sell it for. So here, if let's say again at a quantity of 1, they're willing to sell it for 3, but they're able to sell it for 6. And so this distance here would be producer surplus. So if we wanted to add up all the producer surplus, it would be this area right here. Okay. We're going to call this producer surplus. Okay. Now, using a little bit of geometry, we can actually calculate the total consumer surplus and the total producer surplus for the market at equilibrium. Okay. So to do this, we need to remember the area of a triangle. So if you remember, the area of a square is base times height. And if you want a triangle is half of a square. So we do 1/2 the base times the height. Okay, so if I want to start with consumer surplus, one part is going to be this height here, and another part right here is going to be the base. So if I look at the height, it's 10, it goes from 10 to 6. So 10 minus 6, it has a height of 4. So consumer surplus is equal to 1/2 times the base, which is the difference between, so it's this distance here, 0 to 4, so that's 4. And the height between 6 and 10, which is also 4. Okay, and we can start combining terms here. So 4 times 4 is 16 times 1/2. And so 16 divided by 2, consumer surplus equals 8. Okay, great. Now we can do the same thing for producer surplus. Now, in this case, this is also 4, this is also 4. Very quickly, just by looking at it, we're going to be able to tell that producer surplus is also going to equal 8 at equilibrium. So that's one of the beautiful parts about equilibrium, is that consumer surplus and producer surplus is the same for both. They're able to both have the same amount of surplus. Okay, so all of this together represents the market at equilibrium, and understanding the differences between what consumers are willing to pay, what producers are willing to sell it for, and then what the market price is delivering. So what I'm going to do now is I'm going to clear this all, and we're going to introduce a tax into this system to see what happens to consumer and producer surplus. Okay, let's imagine that the government came in and said, we want to tax this good, whatever it is, at $2 every unit. So for every unit you sell, we're going to tax you $2. Well, if you're a producer, you don't want to pay that $2 out of your own pocket. So what are you going to do? Well, it probably means that you're going to raise your price by $2 and make the consumer pay for that tax, so that you don't have to pay for it out of your own pocket. And so what this looks like graphically is it shifts the supply curve up by $2. So if at this price, or if this quantity, they were willing to sell it for this much, now they're willing to sell it for, so if it was 2, now it's 4. If at 1, it was 3, now it's going to be 5, and so on. All the way from 8, it was 10, now it's going to be 12. So now we have this new supply curve. We're going to call this supply tax. Okay, so with the introduction of the tax, now that shifted the supply curve up. And you notice that when that happens, now what happens to our equilibrium price and quantity? Well, now that's changed. So now right here, we're going to call this P1, or we'll call it PT for tax. Okay, so now it's a price of 7 and a quantity of 3. And we'll call this QT for tax. Okay. So this obviously changes the equilibrium. And so what we want to do is we want to figure out, what does this do to consumer surplus and producer surplus? You remember in our last example, when it's at equilibrium, producers and consumers are getting the same amount of surplus. So what happens here? Well, let's look first at consumer surplus. So remember that this triangle above the equilibrium is consumer surplus. Now you can already see, right, that that is looking smaller. It used to come clear down here into this space, but now it's shrunk up to here. Okay. What about producer surplus? Well, this one's a little bit trickier. We want to find the point at which so the new QT crosses the supply function. So that's going to be right here at this point. So if you come straight down, this is now the new equilibrium price and quantity. So if you come straight down, this is where it crosses the old supply, and we're going to come across here to 5. So that's the breaking point. That's where consumer or producer surplus stops. Okay, so this is going to be our, whoops, I want a different color here. This is going to be our producer surplus. Okay. Now you can see that there's kind of this big hole and gap in the middle here. This is actually a couple parts. So the one part is this middle square. This square right here actually represents the tax revenue. Tax revenue. And that kind of makes sense, right? So if we wanted to calculate the area of this square here, so this side right here is 2, this side right here is 3, so 2 times 3 equals 6. Well, if you did a $2 tax on 3 units, that's the new equilibrium quantity, then you'd end up with $6 at revenue, right? So that's our revenue. So this middle box here represents the tax revenue. But we also have this odd little triangle right in here. What do we make of that? Well, this is actually what we call dead weight loss. Dead weight loss. And this basically means that in this situation, nobody gets that surplus. So what we've gone from is a situation where consumer surplus and producer surplus are equal during equilibrium to now they've shrunk. So both the producer and the consumer are getting less in terms of surplus. And what would have gone to what they would have had in terms of surplus is now going to the government in the form of tax revenue. But not all of it. Some of it actually just gets lost. It just disappears. So that dead weight loss there, that triangle in the middle, represents the surplus that was previously had during equilibrium that now no longer is there. It's just gone. It's wasted. And that's kind of why we call it loss here. Okay. So now in this situation, we would, if you wanted to calculate consumer surplus, producer surplus, you do the same thing, right? 1/2 base times the height. We take the base here and the height here, and we'd calculate the consumer and the producer's surplus. Okay, there you have it. Now you know how to calculate the equilibrium price and quantity. You know how to calculate consumer surplus, producer surplus, and in the case of a tax revenue and deadweight loss. Now, we'll come up with a couple more examples that introduce some different scenarios. So instead of a tax, the government imposing a price floor or price ceiling, and we'll look at how that changes consumer and producer surplus. But keep coming back to this video because the principles of how to calculate each of these are the same. We'll see you in class.